because how many ways are there to solve math?
Many!
Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself.
So the second equation for solving perimeter is?
2 times length plus 2 times width.
Hello and welcome to our elementary edition of Count on Us, where you, the students, call in and you are the star of the show. I am Mrs. Jennerette.
And I am Mrs. Jax.
And we are here to answer your math homework questions. And I know we're doing a lot of work with fractions in 4th and 5th grade,
Yes,
so I hope we get a lot of 4th and 5th graders to call in and ask us those questions about fractions. Because
Absolutely.
I love fractions.
So do I.
And you know we are on Mondays and Wednesdays, 4 to 5 o'clock for the elementary and 5 to 6 for our secondary middle school. Our phone number is 301-772-0080. And yes, look at that, like magic.
Flashing.
It's flashing
telling
at
you,
the bottom.
call us, please.
So call us with your questions. You can also email a question. We have some students and teachers available to answer your email questions. Email us at COU@PGCPS.org. That's COU@PGCPS.org. Email us questions, problems, try to stump one of the students.
Yeah, and I was actually talking to one of the television anchors at my school this morning, and I told her she had such great presence in front of the camera that I would like for her to be one of the students to answer the questions. So I'm going to get in touch with her parent and, you know, just find out if she would be available to meet us here at the studio and maybe answer some questions. So teachers, if you're watching and if you have a student who is well versed in mathematics, and you think they would be a good candidate to answer a question on the email corner, let us know. And, you know, the student can come to the studio and maybe, I'm not sure how we could get a producer over to the school. I'm not sure if that's available, but, you know, they can definitely be taped, and they can be taped answering a question, and they will be the commercial for Count on Us.
Yes, that is so exciting to see the children, the students, work out those problems and help our everyone else in the county.
Absolutely, absolutely. So let's tell you how this works. You might be a new caller or a new viewer, excuse me. Hopefully you will be a caller. But if you are a new viewer, this is how it works. You call us with a homework question or a mathematical problem, and we will solve it together. Actually, you will solve it, and the two of us will just question you to help you solve the problem. Once you solve the problem, your name gets written down on a piece of paper, and we have the amazing treasure box. Your name goes in the treasure box, and at the end of the show, everyone who is called in will have a chance to get their name drawn out of the box for a prize. But that's not it. If you...
Oh, yes.
We're going to let Mrs. Jennerette tell you next.
We have also challenges. And after you get your homework question answered, your name goes in the box, you can participate in one of 2 challenges, and we're going to share those with you in a moment. If you get the challenge correct, guess what happens?
What happens?
You get your name in the box again.
What?
We get to ring our bell, and then
That's
you'll
so
have
exciting.
another opportunity to get picked out of our treasure box, and you will get your gift sent to your school.
All right.
So call in with your homework problems, choose a challenge, get your name in that box.
Okay. A challenge. If I were a first-time viewer, I would probably be thinking, what is a challenge? What are they talking about? I'm so glad you asked
Yes.
because we have 2 different challenges for you this afternoon.
We have let's start off with the one
Our traditional.
yes, the one that we get a lot of calls for. We have our 24 challenge, and what we do with a card, we have 4 cards. There are digits on the card. You have to use all of the digits once, and you can use addition, subtraction, multiplication, division, a combination. All you need to do is to make sure you get to the number 24. So what we're going to do, we're going to look at each card, we're going to read the digits, write them down, figure them out. When you have a solution, call in, and then tell us what your homework question is, and then solve a problem. Let's start with card A. On card A, we have the number 5, 5, 1, and 9. This is a 9 because the red is in the circle, so that tells us it's a 9. So that's card A.
Card B, we have 1, 3, 2, and 7.
I'm going to move this up.
Okay.
On card C, we have 6. Notice there's no red, so I know this is a 6. 3, 6, and 1.
And lastly, but definitely not least, card D, we have 5, 8, 3, and 9. Once again, Mrs. Jenneret told us that this is a 9 because it's filled in with red. And I think we probably need to go ahead and let you know about our second challenge after we get to some of our callers. We know Shakira has been holding on, and we see another caller. So we are going to get started with our show.
All right.
Okay.
We have,
Hello. Welcome to Count on Us.
hello?
Okay.
Hello.
Oh, there she
She
goes.
goes.
Hi, Shakira.
Hi.
How are you?
Good.
What school do you attend?
Potomac Landing.
Oh,
Potomac Landing?
Potomac Landing.
Okay, what grade are you in? Oh, did we lose Shakira?
No.
Okay, Shakira, if you're watching, call us back.
Please.
Okay? Make sure you call us back. Okay? So maybe we can go ahead and continue until our next caller is ready.
All right, so we have 2 challenges, as we said earlier. So let's look at our second challenge. This is new.
Oh, look
called
at that.
Building blocks.
Oh, you know what? We were just told that we have another caller.
Okay, so we're
Okay.
going to show you building blocks in a moment, but we're going to talk to our next caller.
Hello, and welcome to Count on Us.
Uh-oh.
Are we having technical difficulties?
I hope not, because I love math.
Yeah, hello.
Here we go. Hi, how are you?
I'm good.
What is your name?
My name is Sona Bundu.
Sona. Okay, what school do you attend?
I go to Carrollton Elementary School.
Carrollton Elementary. Okay. Do you know Mrs. Njoku? You said Carrollton, right?
Yes.
I think she teaches 4th grade. Mrs. Njoku, she's really tall. Oh, okay.
I know your assistant principal. Tell Miss Bay I said hello.
Okay.
All right, so what grade are you in?
I'm in 5th grade.
5th grade.
right.
Okay, I just want to make sure. And what's your teacher's name?
My teacher's name is Miss Harrison.
Miss Harrison. Okay, I'm going to ask you to do us a favor because I don't know if it's me hearing you from your television. I just hear some kind of feedback. I'm not sure. So make sure you turn the television all the way down and you're only listening to us through the telephone, okay?
Okay.
All right, sounds
Okay.
a little bit better. All right, what is your question today?
I would like to know how to turn a mixed number into an improper fraction.
Okay, change a mixed number into a fraction more than 1. And I know you are probably used to hearing improper fraction, but guess what? We have a new terminology for it. It is now called a fraction greater than 1. Because there's really nothing improper about it.
No.
It just means that the numerator is larger than the denominator. But we don't want to make it like, something wrong with it because you could leave it that way if need be. But it's just going to be a fraction greater than 1, okay?
Okay.
All right, so let's hear that mixed number.
2 wholes and 1/4.
I love it.
Oh, wow, I like that.
I love how she
2 wholes and 1/4.
Okay, what do you know about mixed numbers?
I know that it's more than 1.
Okay, good. What part would be more than 1?
The whole number.
The whole number here. Okay. So do you remember any of the steps for changing this into a fraction greater than 1? No?
No.
Okay.
Can we draw a picture?
We
a
sure
visual
can.
fraction model?
We can draw a visual fraction model. I'm going to try to do a rectangle. I think that's the easiest for me. So, all right.
So you told us that we have a whole number. What is our whole number?
2.
2. And then we have a fractional part. We have our numerator and our denominator. What does our denominator tell us?
The denominator tells us how many total pieces are there in the fraction.
You are so smart. Okay.
So this is why our rectangles are divided into how many equal parts?
4.
4. Excellent
Good
job.
job. So if this is 2 wholes, how would I represent that with these, the first 2 models?
Well, you should shade every square in to make 1 hole, and then do it again to make 2 holes.
You are really rolling today. Good job. Okay, so this is 1 hole, and then if I shade all of these pieces in, this would be 2 holes. I like it. Okay.
You know a lot about mixed numbers.
You sure do. So this represents the whole number. Let's go ahead and see if we can represent the fraction now.
You can shade 1 out of 4 in the fraction.
Okay, why would I do that?
Because the fraction is 1/4, and there's a total of 4 pieces, so you just need to shade them 1 because there's only 1 for the numerator.
Now, what's your teacher's name again?
Miss Harrison.
You tell Mrs. Harrison that she is doing a great job, okay?
Okay.
Give Mrs. Harrison a high five from us because you're actually helping us through this. So I'm going to shade 1 piece in, like you said, because we have 4 total pieces and only 1 needs to be shaded in. And guess what? Now we're still going to do the mathematics behind this, but you can probably help tell us what the fraction greater than 1 would look like. What do you think we need to do?
Multiply?
Oh, well, you're right. For the mathematical piece, we would multiply, but let's just look here at the model. So I'm just going to cover that.
Yes.
What should we do with all of these pieces?
How about this? How many fourths are shaded?
4.
Okay, let's count and see. Count with me.
1, 2, 3, and 4.
Okay, let's count all of the fourths, okay? Because each one of these is a little fourth, right?
Okay.
Okay, so let's count all of the shaded fourths. Go ahead.
1, 2, 3, 4, 5, 6, 7, 8, and 9.
Good. How would I write that?
All the total.
Well, they're fourths, right?
You can 9 out of 12.
Okay.
Ah, I understand why you said 12. Each of our rectangle is divided into how many parts?
4.
4. So our denominator represents the number of equal parts. How many equal parts altogether?
12.
How many equal parts in this model?
4.
And this is 4, and this is 4. So our denominator is going to be 4, because each of our rectangles are divided into 4 equal parts, or partitioned into 4 equal parts.
Okay.
Okay.
Because they're still fourths. Remember, we were counting the fourths. This is 1/4. This is 2/4. This is 3/4. This is 4/4. We can continue. This is 5/4. Count with me.
6/4, 7/4, 8/4, 9/4.
There you
9/4.
go.
So I'm going to write this. Will you read this fraction for me? I think there's like a shadow.
Is it me? Oh, what happened? That's my big hair.
Can you read this fraction for me?
9/4.
Okay, let's read it. 9/4. Now you're right, 9/4, but we're going to say 9/4. So let's go ahead and do the mathematics for this and see if we get 9/4, okay?
Okay.
Do you understand what we did here with the model?
Yes.
Okay, so now I heard you say multiply. Let's see if that is correct. So our first step would be to, do you know what we're going to multiply first?
2.
Okay.
2 times 4.
You are so right.
Good.
So 2 times 4 is what?
8.
8. Okay. And then here's the last step. 2 times 4 is 8, and 8 plus
1 is 9.
yes.
Very good. And you know something Miss Jax did that I really liked? She named each of the models. She counted the fourths, so we could do it this way too. We know this is 4/4. This is 4/4. This is 1/4.
I like that.
And then we
can
can
just
add
add that up.
them.
Look
And
at
since
that.
they have like denominators, what's 4/4 plus 4/4 plus 1/4?
Let me just stick this.
Oh, my hair's in the way. I'm so sorry.
You're fine. Did you see what Mrs. Generette just showed you?
Yes.
And you helped with that because
Yes, you
you
did.
counted. You said you're going to shade the whole thing because it's a whole. We know that when you have a numerator and denominator that is the same, it is going to be one whole. 4/4, 4/4, and then 1/4. We just added all the fourths up. And this is why the denominator is still a fourth.
Yes.
Because you're adding each little fourth together. Okay?
Yes.
Does it make sense?
Yeah.
And now you can see it. I love this part. I wouldn't
you-
have thought to do that.
Me neither. I just thought of it today.
See how many different ways you
Math
can
is the
represent? It is. It's so fun. So fun. Okay. Did you want to do a challenge?
Okay.
Oh,
Okay.
yes. But
Okay.
here's your name for your question. And now tell us what challenge you want to do. I guess we only showed the 24
Yeah,
challenge.
we only had time for. Well, we definitely can show the building blocks. Where is our 24 challenge? Do I have? I have it again. Okay.
Here we go.
So we have 24. And do you know how 24 works?
No, not yet.
Okay.
Okay.
We can definitely go over that. Okay.
So we have cards with numbers, digits on them. The object is to use all of the digits to make the number 24. You can add them, you could subtract them, you could divide, you could do 2 or operations, 3 operations, but the object is to make 24. So what we can do, we can read the cards, and then if you want to write them down and then call us back and tell us which card you want to solve, and then you'll get your name in the treasure box if you get the answer correct, okay?
Okay.
So real quick, card A has 5, 5, 1, and 9. Card B has 3, 2, 7, 1.
Card C has 6. I'm sorry, look at me pointing to the 3. Card C has 6, 1, 6, 3. And card D has 9. This is a 9 because it's filled in with red. 9, 5, 8, and 3. So go ahead and choose a card, write down the digits, try to get to 24, and call us back, okay?
Okay.
All right.
Alrighty.
Thank you.
You're welcome.
All right,
That
so
was fun.
it was. I love fractions, and I know 5th graders and 4th
And
graders, 3rd graders, you will be getting there too. Fractions
Yes,
are a
unit 6.
big deal. And we
Absolutely.
started in 3rd grade, so I'm glad we had our fraction question
Me too.
today.
Very excited.
We have
We do.
another caller.
We have a caller, and I am so happy right now. I'm so excited. Can you take a guess why I'm excited?
Are they from Hillcrest Heights?
Yes, she is from Hillcrest Heights. If this is the Layla I'm thinking about, she is in 4th grade in Miss Karika's class, but I'm not sure. Let's find out.
All right.
Hello, and welcome to Count on Us.
Uh-oh.
Hello?
Hello.
Hey.
How are you?
Good.
Is this Layla?
Yes.
Layla, who's your teacher?
Miss Karika?
Miss Karika, so I was right.
All right.
How are you?
Good.
All right, so we know you're in 4th grade. We know you go to one of the best elementary schools in Prince George's County. And we know you have a really good math teacher. What is your question today?
What is this? A fraction question.
Okay,
Okay.
go ahead.
It says, Kenja's dog ate 3/12 of the treats in a box of dog treats. On Monday, his dog ate 2/12 of the treats on Tuesday. What fraction more of the box of the treats did his dog eat on Monday than on Tuesday?
Okay.
Okay.
All right. Well, what do you know about fractions?
They have whole numbers.
Okay, now we do write numbers on them. We write a number on the top, and that top number is called the what?
The numerator.
The numerator, and then we write a number on the bottom. The bottom number is called the
Denominator.
denominator. Okay. Sometimes you do have a whole number, like with the student who called before you. That student had a question about with a mixed number. So sometimes you can have a whole number with a fraction, but it will be called a mixed number. With the problem you gave us, it sounds like they are just typical fractions. Okay, so it sounds like the problem said on Monday the dog ate 3/12 of the box, and then on Tuesday the dog ate, oh look at that, the dog ate 2/12 of the box. Is that correct?
Yes.
And then we want to know how many more the dog ate on Monday versus Tuesday?
What fraction more of the box of the treats did his dog eat on Monday than on Tuesday?
Tuesday. Okay. So, and I probably should not have put that operation. I know. Okay. As I was putting it, because you saw I was getting ready to write the 2/12 down here, and I'm like, okay, let me just do this. Let's talk about this. Do you think that this is the correct operation?
Yes.
Why?
Because when they say how many more you have to subtract.
You go ahead, Layla. Go ahead, Miss Karika. Okay, all right. So, Miss Karika's doing a great job helping you with that. And I know your mom is very active in the school. She's there often, so she's helping you as well. So, good job. You will be subtracting because it is asking how many more than. So, let's look at our fractions here, and you tell me what we should do. What do you see?
To keep the bottom number.
Okay, we're going to keep the denominator. Why are we going to keep the denominator?
Because they're both the same.
Okay. They are the same. They're both 12ths. Good job. So what are we going to subtract then?
3 minus 2.
Absolutely right. 3 minus 2. So when you have fractions with like denominators, that means that the denominators are the same. You can subtract those. And I just happen to have a little 12th piece here. Not that you can really see what it says, but this is a 1/12 piece. So let's just imagine I have 3 of them on one side. Oh, it looks like we might have some, so we get to do a model. Okay, so as we're getting them together, I'm going to go ahead and write what you said.
Oops.
But we can actually do the model and then
Yes.
write it. So we're going to put 3/12.
That's what the dog had on Monday.
Mm-hmm.
And we're comparing to find out how many more. So I'm going to take my 2/12. And you so accurately said we needed to subtract. Since we're comparing what he ate on Monday and Tuesday, let me put it down here to show.
Okay.
3/12 is how many more than 2/12?
1.
Yeah, you see that one piece over here sticking out, right?
Yeah.
So if we go like this, it's the same amount, but on Monday the dog actually ate this much more. And I love the fact that the fractions are the same because it's the same size piece. So that is very important. This is why when you're adding and subtracting fractions, you have to have the denominators be the same, because the amount has to be the same. Okay, I know you've probably seen equivalent fractions as well, but that doesn't necessarily work because the amount it looks different. But here they're all 12ths, and we're putting them together, 2 12ths over here and 3 12ths, and you can actually see, as Mrs. Generette said, if you pair it up like that, you have just 1 12th more, okay?
Yes.
So 3 minus 2 is 1, but it's 1 12th because that's the amount we're taking away. Okay, Layla?
Yes.
All right. Did you want to try a challenge?
Yes.
Okay, all right.
Well, we still haven't shown our second challenge, so I'm assuming you want to do a 24 challenge?
Yes.
Okay. And Shakira, we see you calling back. We are going to ask for you to hold on, though, because after we do this challenge with Layla, we will go to a break. So just hold on. We see you.
All right. Which card would you like to try today?
B.
B?
Yes.
All right. So on card B, we have 3, 2, 1, and 7. Okay?
Yes.
What do you want to do first?
7 times 3 equals 21.
Okay. So we used our 7 and our 3.
Yes.
Okay.
And 21 plus 2 equals 23.
So our 2 is gone. What's next?
23 plus 1 equals 24.
All right. Guess what? I'm going to put it here, and I'm going to ask you, does it make a difference? Does it make a difference that I put 1 plus 23?
No.
I still get 24, right?
Yes.
Because of the commutative property. Okay. So, good job,
I got to ring the bell. I'm so excited. So I have your first name in there, and now I'm going to write it again because you got the challenge right.
All right, Layla, so your name is in there twice. Hopefully someone from Hillcrest Heights will win. Not that I don't want, someone else from one of the other schools to win, but Layla, this is your second time calling, so I hope that you have a chance. But we, of course, will make sure it's fair. You will see us go in and pull out. It's all a game of chance, better known as probability in the mathematics world.
So we have 2 Laylas. So your probability is more than likely.
It sure is. Okay.
Great job, Layla.
Thank you so much for calling.
Thank you.
All right. So we do see that our callers are definitely calling us back. Shakira, we see you. And so now we see you. Hold on, okay, because we do have to go to a break. Make sure you work out those problems, and we can go over them when we get back.
All righty.
Okay, see you on the other side.
Hello, my name is Jessica and I attend James Ryder Randall Elementary School. I am in the 5th grade. Today, the math problem is, during some months, Earth revolves around the sun in 30 days. How many seconds is this? Well, there's 24 hours in one day. So in order to find the hours in 30 days, I must multiply 30 times 24, which equals 720 hours. In order to find out how many minutes are in 720 hours, I have to multiply 720 times 60 because 60 minutes equal 1 hour. And that equals 43,200 minutes. Next, in order to find out how many seconds are in 43,200 minutes, I must multiply 43,200 times 60, because 60 seconds equal 1 minute. And that equals 2,592,000 seconds. So 30 days equal 2,592,000 seconds. Woo! That was a lot of seconds. I hope you found the solution to your problem easy to follow. This is Jessica from Counting Us. Bye. See you next time.
Hey you, yeah you, sit right there, I gotta tell you something. I bet you know someone with type 2 diabetes. Guaranteed, you know why? Because 1 out of every 3 little kids is gonna develop diabetes in their lifetime. That can lead to heart problems, strokes, and even blindness. I'm John Sally, and I'm telling you, it ain't gotta be that way. Now you can up your defenses by eating more fruits and vegetables, having more vegetarian and vegan meals. These steps can be the power plays to protect you and your family against the risk of diabetes. To learn more, go to blockdiabetes.org. Okay.
He was so inspiring.
He took chances.
He was so moving.
He lived daringly.
Martin Luther King Jr. was a man of service, and his day shall be a day of service.
He inspired us in words, but he led us in deeds. To honor him, let's do the same. Go to mlkday.gov and find out how to volunteer on Martin Luther King Day and beyond. This message is brought to you by the Corporation for National and Community.
Okay, guys, ready? Here we go. Let's smile and brush our teeth twice a day, every day. Let's smile and floss our teeth once a day, every day. Let's keep that smile a happy place on your face with good nutrition and dental visits. Let's smile. Let's smile. Let's smile. Let's smile.
Welcome back to Count on Us. We have some callers waiting. I'm so excited. And I'm even more excited that it says fractions. We had fractions questions this first half of the show, so that's wonderful. We have never shown the second challenge.
Okay, we can quickly show it and then
real
go
quick,
to Shakira
and
because
then
we know she's been
Shakira's been waiting, and we're going to get to you, Shakira. But real quick, we showed the 24 challenge. We're familiar with that. Now we have our building blocks. And what we have are 4 blocks with the digits 8, the number 5, 40, and 10. Then we have some blank blocks over on the left, and they equal different numbers. The first 3 blocks need to equal 30. So guess what you're going to do?
What can we do with this?
We're going to take blocks and make them equal 30. So maybe you can add 3 of these blocks, subtract, multiply, divide, I don't know. But 3 of these blocks, you do something with these 3 blocks, 3 of the 4 blocks, 3/4 of the blocks, it'll equal 30.
Or could you use 1 block over and over and over?
Oh my goodness. We're going to say yes.
All right.
Why
so
not?
this is an open-ended question, and you all should be seeing these types of questions. Oh, you cannot. Our producers just told us you cannot use the same blocks over and over.
So I can't use 10, 10,
So we're
10.
restricted here.
Man.
Okay. You're going to have to use 1 of the, or 3/4 of the blocks, as Mrs. Generette said, 1 time only to get to 30, 120, or 16.
That's a fun challenge. I hope somebody calls in and does that challenge. So that's our second challenge. And of course, we have our 24 challenge. We had Layla.
Yes.
She did card B. So if someone else wants to do card B, but you do it a different way, feel free. But then we have card A, C, and D.
Absolutely. And Shakira, we are coming right to you right now.
Hello. Is this Shakira?
Oh.
Uh-oh. I hear me. I don't like that because I don't like my voice.
Oh, turn your television all the way down. Okay. All the way down. Shakira, you've been holding for so long. Come on.
Stay with us.
Turn the television all the way down and just listen through the telephone, okay?
Intercepted. It was a risky pass.
Yeah. Shakira. All right, I'm not sure what's going on. We're going to have to go to our next caller. I feel bad because she's been holding. Shakira?
Are you there?
Yeah.
Hi, Shakira?
Yes.
Okay, turn your TV all the way down and just listen to us through the phone, okay?
Okay, can you hear us? What do you think?
I don't know what's happening. I want you to stay, but I can still hear myself, so I don't know what's going on.
We may have to go to the next caller. Yeah.
All right. Well,
we can hear you on your television. We can hear us on your television.
But we can't hear you, so I don't know what's going on.
Okay.
Try again, Shakira. Sorry.
All right. Our next caller, we are ready for you.
Oh.
Hello. Welcome to Count on Us.
Hello, hello. What is happening?
I don't know, but I can hear you crystal clear in my earpiece. Anyone out there? Anyone?
Oh, well.
Not sure. Okay. All right, maybe we can try the next caller.
All right.
I'm not sure what's going on.
And it's...
Hello and welcome to Count on Us. How may we help you?
Uh-oh.
I hear a voice.
I'm so excited. And it's not our voice.
Hello.
Hi. What's your name?
Kyra. Hey, Kyra, I'm getting excited.
I'm getting
excited. You know why, Kyra? Do you know why I'm excited right now?
No.
You have no idea? Kyra, what grade are you in?
4th.
You're in 4th grade. Who was your teacher last year?
Miss Hallman.
Say that one more time.
Miss Hallman.
Miss Hallman. What school do you attend?
Hmm?
What school do you attend?
I used to go to Brandywine, but now I switched to Walden Woods.
Oh, so you were at Brandywine last year. I was at Brandywine last year.
No.
Yes, I was.
You're funny. I like you.
So you're at Walden Woods.
Yeah.
All right.
Who's
you
your
know
teacher
Miss
at
Cobble, huh? Do you know Miss Cobble?
Yes.
Yes, you know Miss Cobble. And I know your principal. Okay, I'm sorry. All right, so who's your teacher at Walden Woods?
Miss Hallman.
Miss Hallman. Who was your teacher last year at Brandywine? Oh, wait, you were at Walden Woods last year.
Yeah.
Okay, and you're at Brandywine this year. Okay, that's what I was getting ready to say. You should know me. Okay, anyway. What is your question for today?
I need help on a fraction homework problem.
A fraction homework
Fractions.
problem. Okay, 4th grade.
Fractions action today. All right. What's your question?
It says, the salad at Hallman's fruit stand has 1/3 bananas, 2/4 strawberries, and 1/6 blueberries. Use what you know about fractions to explain which fruit makes up the most of the salad, which makes up the least. Use words, numbers, and a fraction matter to show your work.
Okay.
We got a lot of stuff going on.
So 1/3 represents what fruit? I heard blueberries and bananas. Which one is 1/3?
The bananas.
Okay, so bananas, 1/3. What's the other fruit for 2/4?
Strawberries.
Strawberries. Okay, and the last fruit for 1/6?
Blueberries.
That sounds like a good fruit salad.
Mm-hmm. And this is a great problem because I am going to draw something for you. It's one of my favorite things in the world.
Oh, and you wanted to do a number line today.
I did. Okay. I drew a number line. Can you see it?
Yes.
Here is the number 0. Here is the number 1. Kyra, can you tell me what this line represents?
The number 1/3.
Not quite. Now, I may have been off a little bit. What's halfway between 0 and 1? Ignore these. And let's just look at the number line. This is right in between. I have partitioned 2 equal parts. So if this is 0 and this is 1, what's halfway between 0 and 1?
0.
Let's look here. Is this line, where is this line? Is it
in the middle?
In the middle. Good.
Okay.
So if I'm in the middle of 0 and 1, am I going to be more than 1?
More.
Okay. I just want to show a demonstration. Here's a piece. Let's pretend this is the number line, okay? I'm actually going to draw a line on here. My line is kind of crooked, but watch what I do with the paper. What did I just do?
Rip it
Ripped it how?
in half.
Okay.
So pretend my line has been partitioned in half. What would this be? What fraction would this be?
1/2.
1/2. Very good.
Good job.
Because we're going to use this number line to talk about 1/3, 2/4, and 1/6. Because we want to know which fruit has the least, you said?
Yes.
And the most, right?
Yes.
Okay. So let's look at the fraction. Let's just start here. Let's look at 2/4. Because with math, you can do things so many different ways. So we're not going to look at 1/3 or 1/6 because I want you to tell me all you know about 2/4.
Okay.
And I'm going to show 2/4, I hope. What do you know about 2/4?
That I don't really know.
Okay, so let me show you 2/4. Here's 2/4. You see it's yellow on yellow, so I don't know if you can see that. 1/4, 2/4. I want to use my fraction 1/2 because 1/2 is a nice friendly fraction. It's a benchmark fraction. We know a lot about fractions. So I'm going to find my fraction bar that says 1/2.
Okay.
So here's my 1/2. What can you tell me about 2/4 and 1/2?
1/4 is, 1/2 is, like a circle or something. Then you put a line through, then shade in 1.
That is true. I could draw 1/2 like this and shade it in. But what about, okay, you like circles. Let me draw another circle and cut it into fourths. What would I do with that circle?
Shade in 2.
Shade in 2. Whoops.
Good job.
So tell me about these two circles. This is 1/2. This is 2/4. What do you notice?
That on 1/2 it's only shaded in 1, and 2/4 only have 2 shaded in.
Yes, you're absolutely right. Let's look at our fraction strips. What can you tell me about this 1/2 and these 2/4?
The 2/4 are like cut into 2 pieces, and the 1/2 is not.
Very good. That is very true. And then something else I see, they are the same size.
Oh.
Do you see that?
Yes.
1/2, our brown strip, is the same size as my 2/4, which are yellow. They're the same size rectangle. If I traced it, they would be equivalent or equal. And with our circles, 2/4 and 1/2 the same amount of space is shaded. So what does that mean? 2/4 and 1/2 are what?
Equivalent fractions?
They're equivalent fractions. Very good. So that means on my number line where I have 1/2, I can also put 2/4 in that same spot because they are equal. Okay? So I'm going to just leave my 2/4 and 1/2, and I'm going to find a third, hopefully. Here is my 1/3. What can you tell me about the relationship between 1/3, 1/2, and 2/4?
They're like a rectangle, but 2/4 and 1/3 are not broken.
1/3 is not broken. Very good. We knew that 2/4 and 1/2, 2/4 were broken, 1/2 was not, but they were the same size. Is 1/3 the same size?
No.
What can you tell me about 1/3?
1/3 is like, it's not like a rectangle, but it's like a square.
They're all rectangles.
Oh.
Let me move it out the way. You see how this one, all 4 sides aren't the same? So these are all rectangles, but which rectangle is the smallest? The 2 yellow, which is 2/4, the brown, which is 1/2, or the green, which is 1/3?
The green one.
The green one. 1/3 is less than 1/2. That's because if we use our fraction bars to show as a model, it's not as long. We need more to equal 1/2. So on our number line, would our 1/3, where would our 1/3 go? This side of 1/2 or to the right of 1/2?
The right.
Over here?
Yes.
So when we go to the right of our number line, what happens to our numbers? Do they get smaller or do they get larger?
Larger.
They get larger. Is 1/3 larger than 1/2?
Yes.
This is the 1/3 here, and this is the 1/2. Which one is larger?
1/2.
1/2 is larger. So 1/3 is smaller. So 1/3 will go somewhere to the left of 1/2, because when we move to the left, our numbers get smaller.
Okay.
So 1/3, we're going to put it over here.
Okay.
So now I'm going to get, I hope, 1/6.
Perfect.
Can you see my orange? And this actually is a square, which is a type of rectangle, so they're all rectangles. What can you tell me about 1/6?
It's smaller
Than?
Than 1/3, 1/6, and 1/2.
So 1/6 is smaller than 1/3, so we know 1/6 is to the left of 1/3. So here's our models. We have a number line. So which one is the most? Which fruit is the most?
1/3.
Okay, so this is the blueberry.
Good. Here's the, was that banana?
I think so.
And strawberries.
This is strawberries. Which fruit had the most?
Strawberries.
Okay, good. Strawberries has the most amount. What is the smallest? Which fruit represents the smallest amount?
Blueberries.
Blueberries.
Very good.
Okay. Does that help to answer your question?
Yes.
All right.
All right. We did a lot of models and number lines, so
We did.
we're going to keep working with that. And would you like to do a challenge?
Yes.
All righty. Which challenge would you like to do?
Do you have the challenge written down and worked out already?
Yes.
Oh, okay.
I would like card A.
Okay.
Card A. And those numbers are 5, 5, 1, and 9.
Okay.
I'm going to do this before I forget. Your name is here.
Good job.
All right. Challenge time.
5, 5, 1, and 9. Let's go.
Okay.
What do you want to do first?
Do I have to add, subtract, multiply, or divide?
Okay, so what you need to do is write these 4 numbers down, and you can use any of the 4 operations. You can add, subtract, multiply, or divide. It's up to you, but we want you to figure it out and then call us back, okay?
Okay.
And the goal is to reach 24, okay?
Okay.
All right.
Good job.
Thank
you for calling.
All right. Welcome to Count on Us. What's your name? Hello?
Hello?
Yes. We need you to turn your television all the way down and only talk to us through the telephone.
Okay. I don't know if you can hear us. Can you hear us?
We can't hear at all.
I don't know what's going on.
I'm not sure. Is this Shakira again?
I think it's Shakira
yeah,
again.
Shakira, I'm not sure what... Oh, okay.
Well, okay, I'm sorry. Is this Felicia?
Yes.
Felicia.
Oh, yeah, there you go,
okay.
Felicia. Sorry, Felicia.
I thought it was Shakira. I apologize. Felicia, what school do you attend?
Cherokee Lane.
Cherokee Lane.
All right.
Okay, Felicia, you used to call us last year. Okay, so what grade are you in?
5th.
All right, let's go with your question.
What is 8 over 6 times 1 over 5?
Can you say that one more time? Did you say n over? Say it again.
8 over 6 times 1 over 5.
So 8/6 times 1/5. Correct?
Yes.
Okay. What do you know about multiplying fractions?
You just have to multiply the number across from your numerator.
Okay. So we're going to multiply across the numerator. So we have 8 times 1. What is 8 times 1?
8.
Good. So what else do you know about multiplying fractions?
Then with the denominator, you also have to multiply both denominators across from each other.
Okay, so we have 6 times 5, which is?
30.
30. So our answer so far is 8.
8 and 30 times.
8 30ths. What do you know about the 8 and the 30?
You can divide it by 2.
Ah, I like how you said 2. Why did you start with 2?
Because both 8 and 30, they share 2.
You can take 2. I know 8's an even number and 30 is an even number, so all even numbers, if I don't know anything, I know even numbers can be divided by 2. So what's 8 divided by 2?
8 divided by 2 is 4.
It is 4. And what's 30 divided by 2?
15.
15. You think we're done?
Yeah.
Why?
Because the numerator is an even number, but the denominator is an odd number.
Okay, I'll give you that, but I'm not sure that that works all the time. Why are we done for this particular problem?
Oh, I got one. Oh.
Yeah, because we done.
Oh, the numerator is bigger than it's less than the denominator.
Say that one more time.
It's less than the denominator.
What's less than the denominator?
The numerator 4 is less than 15. And the denominator is never supposed to be on the top.
Okay, I agree with you that the numerator is less than the denominator, but why is this already in simplest form? What are we not able to do?
You can't divide them evenly.
You can't divide it anymore by one digit, correct?
Yes.
Okay. So it's not, and I just want to be clear because I think that's a misconception when students see an even number and an odd number, and you think, oh, it's in simplest form. Not necessarily. It's in simplest form when there is no other number besides 1 that you can divide evenly into the numerator and denominator. Quick example, 15 over 30. 15 is an odd number, is that correct?
Yes.
And 30 is an even number. But guess what? 15, this is not simplest form. You can divide this again. 15 goes into 15 one time, and 15 goes into 32 times. So it actually simplifies into 1/2, okay? So I just want to be clear that when something is simplified, it just means that you cannot divide that fraction anymore by one number besides 1, okay?
Okay.
All right, Felicia. So I think we may have time for a quick challenge, and
yes,
we're gonna have. Do you have the challenge worked out? If you want to do one, do you have it worked out already?
Can I see the challenges?
Okay, we can go ahead and show the challenge.
We have our 24 challenge,
and we have building blocks. Which one did you want to do?
Let me show you the building blocks.
I want to do the one with the numbers on them, A, B, C, and D.
Okay, which one? A, B, C, or
D? B?
D? D as in David, or B as in... Okay. Now, were you watching earlier when Layla solved this already?
When who?
We had a student call in, and she solved this. So you can definitely go ahead and try it, but it has to be solved in a different way, okay?
Okay.
All right. So whenever you're ready.
3 times 7 equals 21.
Okay.
Let's see if you do something different.
What's next?
Next, you can do 21 plus 1.
Okay. This is different, isn't it?
It is
okay.
different, yeah.
All right, what else?
We have 2 left. So 22 plus 2 equals 24.
All right. Okay.
I get to ring the bell.
Ring that bell. Okay. All right. So, guess what? You are the last person to go in our treasure box for the day. What is all of that feedback?
I don't know. But we have Felicia in our treasure chest twice.
Yep. We have Layla in there twice. We have...
I think it's over there.
We have... who was our last?
We had Layla and Felicia.
So Felicia's in there twice. Layla's in there twice.
There's your other one. We do not want to cheat Felicia.
And we see callers on hold. We definitely want you to hold on for the middle school show. We have some experts coming on.
Yes.
They are expert
Very
mathematicians.
knowledgeable.
And you can ask them anything and they will be able to answer it for you. So this is the end of our elementary show. We are going to shake up the box, shake it up one more time. And we're going to see who our winner is. I want you to pick because, you know,
yes.
We're gonna make it fair. Let's see who it is.
Oh, wow. It is Felicia from Cherokee Lane.
All right.
Good job, Felicia. Congratulations.
We have a different bell.
Oh, look at that bell. I like it.
Okay. Thank you to all of our callers and viewers today. We appreciate you calling. Remember, every Monday and Wednesday we are on, and you can always count on us. Welcome to your mini lesson today. My name is Mrs. Jacks, and today we will discuss how to change mixed numbers into improper fractions, and the reverse of that, how to change improper fractions into mixed numbers or whole numbers. Let's go ahead and look at an example. In this example here, once again, it says changing mixed numbers to improper fractions. We have a mixed number here. A mixed number is when you have a whole number paired with a fraction. This one happens to be 3 1/8. We're going to go ahead and change that into an improper fraction. The first step is to multiply the whole number by the denominator. So 3 times 8 is 24. After you do that, well, let me go ahead and show you. 3 times 8 equals 24. You have the numerator here. We're going to go ahead and now add the numerator to our product. 24 plus 1 equals 25. This final answer becomes your new numerator, and the denominator stays the same. So 3 1/8 changed to an improper fraction happens to be 25 over 8. An improper fraction means that the number on top, which is the numerator, is greater than or larger than the number on the bottom, which is the denominator. We can also reverse this. We can change improper fractions back to mixed numbers, and I'm going to show you how to do that now with this second example. Changing improper fractions to mixed numbers or whole numbers. This first one here is an improper fraction. Once again, that means that the numerator is larger than the denominator. The first step is to divide the numerator by the denominator. Okay, so I'm going to set this up as 56 divided by 7. If you already know the answer, you can of course put the answer here, or you can set it up the long way using an algorithm. 7 goes into 56 8 whole times. 8 times 7 is 56. And then with the algorithm, you will go ahead and subtract, and your answer is 0 here, so you don't have anything left over. There's nothing else to continue dividing by. So your answer happens to be 8. So in this case, you can change an improper fraction to a whole number. Let's look over here. This one is a little different. This is 55 divided by 7. So it's one number less than 56. Let's see what happens when we do that. 55 divided by 7, we will do it the same way. 7 goes into 55. It doesn't go exactly 8 whole times. It's going to go in 6 times, and then we're going to have something left over. So let's go ahead and set up the algorithm. 55 divided by 7. Well, I'm sorry, I said 6 times. Excuse me. It goes in 7 whole times. So 7 into 55 is 7. 7 times 7 is 49. To complete the algorithm, you need to go ahead and subtract. 55 minus 49 gives you 6. So 6 is your remainder. Now, to set up our answer, the whole number here becomes our whole number for the mixed number, and then the remainder becomes the new numerator, and guess what? The denominator stays the same. So 55 sevenths, which is an improper fraction, now becomes 7 6/7 as a mixed number. Once again, this was a short mini lesson on changing improper fractions to mixed numbers and changing mixed numbers to improper fractions. Thank you for your time.
Minds can achieve anything. We make sure they get to college. Federal student student aid provides more than $150 billion in grants, loans, and work-study funds to make college possible for anyone with the mind to get there. Because if given the chance, minds will do great things. Federal Student Aid, proud sponsor of the American Mind. Learn more about money for college at studentaid.gov.
Because how many ways are there to solve math? Many!
Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself.
So the second equation for solving perimeter is?
2 times length plus 2 times width.
Good afternoon and welcome to the secondary session of Count on Us. We are a homework hotline. We are here to help you with any math problems you may be having on your homework this evening. My name is Ms. Walters and this is
I am Mr. Pugh, your regular, Mr. Wednesday. That's my nickname, Mr. Wednesday, Mr. Pugh. I'm working with the boss today.
It's good to be here today, though. I hope that we have some callers out there who are going to dial in. The number is 301-772-0080. We want to hear from you. I know our middle school callers, they should be home from school by now, don't you think?
Yes, they should be.
I think so. Call us in. Even if you don't have a homework problem, call us in. Tell us what you've been working on in school. Maybe we can give you some additional strategies to work with so that we can make math more efficient.
But also, as you all know, we watch the show for so many years, we always have challenges for our students out there. So when you call in the show and ask us a question, we're going to always ask you, do you would like to try a challenge? And we have 2 challenges this evening. The first challenge is building blocks. Remember, you can use any 4 of these numbers and any operations to get up these solutions. But I believe it has to be the same 3 or 4 numbers every time, is there?
No, it has to be a different number.
A different number. I didn't know that.
So
wow.
They have to use 3 of these blocks in each of these equations, and they have to input what operation they'd like to use in order to get this solution of 30, 120, or 16.
Wow. Okay, and our second challenge is the classic. You know it. We know it. It's the challenge what? Bank take control. That's challenge 24. You know A, B, C, D. And that is a 9, ladies and gentlemen. When it's shaded in, that is a 9. That is a 6. And as always, we ask you to copy the problems down, the digits down, and have it worked out before you want to solve it on the air. And this is a challenge for you. The single dot means it's easy. To the 3 dots means it's most challenging. So if you're not that good, you want to try something in the middle. Or practice something easy.
Sometimes the 3 dots, you can see it really quickly.
I can't see any of them.
No?
Maybe we'll have Miss Walters, who's our boss, our math expert, show us one later on in the show, and we can get no takers for it, okay?
Yes, maybe.
Great. So I see that we have one call already.
Oh, okay.
Would you like to take the? I know she's been off the air for a while. She's been behind the scenes doing her little mojo.
But I've been listening.
So what I'm gonna do is let her take the first call because she is the one and only Miss Walters.
You are so silly.
I'm Mr. Wednesday, but that's Miss Walters. Did I tell you that's Miss Walters? Everybody, that's Miss Walters.
Hi, we have a caller. Hi, is this Shakira?
Yes.
Hi, Shakira. How are you today?
Good.
Good. What school do you attend?
Potomac Landing.
I'm sorry?
Potomac Landing.
Potomac Landing. Okay. And what grade are you in?
Okay. Fifth.
Sixth grade?
Fifth.
Fifth grade. And who is your teacher?
Miss Oliver.
Miss
Oh,
Oliver.
tell Miss Oliver, say the Count on Us crew said, how you doing, Miss Oliver?
All right, Shakira, what can we help you with today?
How to change an improper fraction into a mixed number.
Okay.
Do you have a problem in mind?
11 over 8.
All right. So we have 11 eighths. All right. And we noticed that. Why do we call this an improper fraction, first of all? Do you know why?
No.
Well, normally, well, not normally. Well, I can say it's an improper fraction because our numerator is larger than our denominator, which means we can make a whole and then have some more eighths left over. Okay? So how we do that is we figure out, well, how many eighths can I get out of 11? Can we get one whole piece out of 11? If we had eighths?
Yeah.
Yes. So we can get 1. And that 1 takes up how many eighths?
It takes.
In other words, we have 8 eighths is the same as 1 whole, yes?
Yes.
So we took 8 eighths away from 11 eighths. So how many eighths do we have left over?
1.
Well, we have more than that. If you divide 8 into 11, it goes in 1 time with how many left over?
Oh.
Just count up. If you had 8 divided into 11, 8 goes into 11 1 time. When you subtract, what is your difference?
Oh.
I can't hear you, Shakira. Can you speak up a little bit?
Minus 7.
Well, actually, if you take 8 away from 11, you will get 3 left over. And when we represent this 3 left over, we represent it as the fraction 3 eighths. So, when we change our improper fraction of 11 eighths to a mixed number meaning it has a whole number, excuse me, a whole number and a fraction, our solution will be 1 3 eighths. Okay?
Okay.
All right, great. Shakira, did you want to try a challenge?
Yes.
Okay, which challenge would you like to try? Our 24 challenge, as one of our talents used to say, or
our building blocks. And before you try a challenge, Shakira, I'm going to let you know right now your name is going in our treasure chest.
Because we treasure all of our callers.
Take those O's on out. And right now, you have a 100% chance of winning. So continue to watch the show. So which challenge would you like to try, Shakira? Building blocks or challenge 24?
The 24.
All right. So now, Shakira, you want A, B, C, or D?
B.
B, right here. 1, 4, 5, 7. Now, can you do me a favor, Shakira? Can you, now, you'll be going to hang up. We'll let you go. We want you to work on these problems, challenge 24, and call us back, okay?
What are the numbers again?
You ready? Let me know when you're ready. Are you ready?
Yes.
1, 4,
It's
5.
1,
1, 4.
Wait.
Okay, let me know when you're ready.
It's 1, 4,
5,
5,
7.
7.
Okay? And
Okay.
remember, you can use any operation, but you have to use all 4 digits only one time, and your final solution, which is your answer, must be what? 24.
Okay.
All right, have a good day.
All right, bye, Shakira.
Oh, it's such a great job watching a professional solve these questions. How can I do it like you?
I love working with you.
She likes all the compliments. All right. Let's go to our next caller. Caller, are you there? Muhammad? Muhammad.
Yeah.
How you doing, Muhammad?
Yeah.
What school do
I'm
you
doing
attend?
fine.
What school do you go to?
Charles Carroll Middle School.
Charles Carroll Middle School. Now, Muhammad, I want you to do me a favor. Can you turn your TV down, please?
And just listen through your earpiece, okay?
Thank you. Listen through the phone. So, you go to Charles Carroll Middle School. Great school. Great job. And how can I help you this evening, Muhammad?
I'm doing the circumference and the distance around a circular object.
Oh my goodness!
And my
I like those
question
words.
was,
Yes. Go ahead.
And my question was, what's the formula like for a circle, the radius? Like, what's the formula for the circumference? If I was trying to get the radius for a circle.
So I'm gonna give you an example. Watch the TV screen. So here's my circle. Boy, that's a good circle by freehand. You know what I mean? That's a great circle by freehand.
Great, Mr. Pugh.
So that's my center of my circle, correct? All right. Here's my diameter. I'm talking about radius. I'm sorry. Woo. That's my radius. I'm gonna use my diameter as a quadrant. That's my diameter. And you see your circumference is the measure around the circle, correct? That's your circumference. Now, to find circumference, you have so many different formulas you can use. To find circumference, you can say pi times d, which is your diameter, okay? Hello?
Uh-huh.
And we all know that diameter is always double your radius. So, or you can use this formula here. Circumference represented by big letter C is 2 pi r. Okay? So these are your two formulas you can use to find circumference of a circle. Now, if they gave you a circle or they gave you dimensions, you can just substitute those dimensions for one of your variables in either equation. Because sometimes what they're going to try to do now in the future is trick you. They're going to give you your circumference and ask you to find your diameter or find your radius. So you have to be able to manipulate, I like that word, manipulate your formula.
So how would you do that, Mr. Pugh?
How would I manipulate the formula?
How could you find, if they give you circumference, how would be able to find the diameter?
Oh, Muhammad want to say something first.
Okay, go ahead.
Yes, Muhammad? Muhammad?
What does pi equal?
Oh, great question. Muhammad, I love these big questions. You're making me work hard this evening. My brain is hurting. Pi. So we all know this is the universal symbol for pi, correct? That's pi. Pi, it's a number that never ends, okay? Hello, Mom, are you hearing me?
Uh-huh.
Pi never ends. But in the math world, we use it, we shorten it up. We say pi as a decimal is equal to 3 1400. I'm about to say it right tonight because my balls are sitting right beside me. She really hit me while we off the air. So, but also, and I always tell my students this, because sometimes as you grow and mature in your math, they give you questions with fractions with pi. And sometimes they have a hard time with fractions. So I want to show you pi as a fraction as well as a decimal. So as pi is equal to 3 1400, it also equals 22 over 7. That equals pi as well. So what does pi really equal? Pi is equivalent to right now, for our math, when we shorten it up, 3 1400 or 22 over 7, which is the same thing. Okay? I learned this a long time ago. Pi never ends, it never repeats itself. Every single phone number, every single digit, every single social security number is in pi.
Oh, really?
Think about that. Okay. Any more questions, Muhammad?
I think Muhammad.
Muhammad, no more questions?
No.
I think we did a good job. So he just hung up on it and said, I'm done.
You answered this question.
But let me continue to show you how you manipulate this really quickly.
Yes, quickly.
That was a good question. Can I erase some of this and rewrite it?
Sure.
Sometimes I step back and just look at my work like, oh
I'm
my
curious.
God. It's curious. So right. Any formula. C, the 2 pi. Oh, let's use that one.
Okay.
So now, I always tell my students, formulas, it's a formula. You can just use a formula to help you solve things, but you can solve for any variable in the formula. And sometimes they trick you by asking for what's already what the formula is looking for. So if they gave me circumference, they asked me to find my radius.
Okay.
So now I always tell my students, we're going to use the PO. PO. People always pronounce my name. They don't say Mr. Pugh. They say Mr. PO. I say no. But PO is properties of equality. So inverse operations, basically. So I want to divide, because these all be multiply, right?
Yes.
I'm going to divide this side by 2 pi.
The inverse operation.
Inverse operations.
Okay.
So I want to get rid of, but when I do the one side, I got to do the what?
Other.
That makes I got to keep it balanced, keep it equal, properties of equality. So now, doesn't pi cancel out?
Yes.
Doesn't 2 cancel out?
Yes.
Doesn't it leave r on this side by itself?
Yes, it does.
But these are not the same. These are not constant terms. So I just leave those like this. So if I was solving for r, I would take my circumference divided by my radius times 2, which is 6.28. I'm sorry, 6 and 2800.
Thank you. Because it's 2 times 3 and 1400.
Because 3 and 1400 times 2 is 6 and 2800.
Yes.
I would divide that into my circumference, and I would have found my radius.
Okay.
All right, I think Muhammad called us back.
Oh, Muhammad, you want to find something else. All right.
I was doing an extension on your lesson, Muhammad, on your question.
What can we do for you this time, Muhammad?
Make sure what's his name now?
Say it again?
Yeah, what does the radius equal?
Okay. The radius is always half your diameter. So let's look at this. Once again, that's not a bad circle, but that's not the one like I had before. All right, now, Mom, are you watching the TV screen?
Yeah.
All right, now do me a favor. I want you to listen to me through your telephone and turn your TV down.
Okay.
All right, now, your radius. You know your radius is the center of the circle to any point on the circle. Okay? That's your radius. Okay? It's from the center of the circle to any point around to the circle. I asked him 4 times already. Let me do.
Turn your TV down,
let me jump to his
Muhammad.
phone. Okay, look. Okay, with the Muhammad. So your radius is the center of the circle to any point on the circle, okay? And I want you to see something though, Muhammad. Your radius is always half your diameter. Because your diameter, I just light bulb. All right, now look, because your diameter goes from one point of the circle through the center of the circle to another point of the circle. That's your diameter. Your diameter cuts the circle in half. Okay?
Uh-huh.
Any other questions, Muhammad? Did I help you with that one?
Can I do this?
Oh,
then?
please jump in, boss.
The diameter would equal 2r.
Oh, my Lord, yes, it will.
You understand why, Muhammad?
Yeah. And say that I was doing the volume of like a cylinder.
Okay, hold on one second.
So, like,
okay, go ahead.
What's the formula for the volume of a cylinder?
Okay.
Do you have a problem on that, Muhammad, that we can go through with you?
Huh?
Now, Muhammad, let's pay attention. I mean, Mom, I'm helping you out because you must be learning about formulas. Charles Carroll must be on it right now because you pushing the limit with me right now. You went from circles to cylinders all in one mix. Oh, I tell you, if I wasn't comfortable with myself in math, I'd be nervous right now. Okay, here we go, Mom. Here we go, Muhammad. Here we go. Here we go, Mom. Here we go. So volume means I got to find a three-dimensional object. Yeah, it's 3 dimensions, okay? But I got to use the surface area of my circle. So in order to find area of a circle, how you find area of a circle? So I'm going to say my base is my area of my circle. So for my B, I'm going to say pi r squared times my height.
Muhammad,
you hear me?
I need for you to turn your TV down because we keep getting feedback. Turn your TV all the way down and just listen through your telephone, okay?
So Muhammad, to find the volume of a cylinder, I'm going to multiply my base times my height. And I want you to notice, my base is a capital B. That capital B lets you know that really stands for a different type of formula. It's not a lowercase b, it's a capital B, because that B stands for the surface area of a circle. So I got to find the area of that circle multiplied by its height, which this looks like right here. Height, and I got to find my base. Okay? Okay, Muhammad? Great job, Muhammad. Thank you so much.
All right.
All right.
Good job. Wow, I learned a lot.
I know one thing. I'm sweating. I put out my cat. That's a good job.
All right, girls and boys, please remember when you call in to turn your television down. Because what you want to hear yourself on television, but what we hear is feedback on the air. And it's difficult to understand what you're saying because we can hear ourselves in the background. Okay?
Did we put Muhammad's name in the chest?
I put his name in the treasure chest.
So Muhammad, continue to watch the show. At the end of the show, you might win our grand prize this evening. And also, Muhammad, if you want to try China's 24, call us back.
Yes.
Try China's 24 or building blocks.
Let's show them the Challenge 24 numbers again so they can be ready. All right, our card A has 14, 9, 3, and 2. Our card B, B, 7, 1, 5, 4. Card C, 7, that's a 6, 8, 2. And card D has 5, 2, 8, 8.
Well, let me try one right quick for you guys.
Okay.
I'm gonna try the easy one because I know I'm not that good at math.
Oh, what?
And I know my student out there from I think what school was Shakira from? Potomac Landing.
Yes.
I know she's still trying to solve her China 24, and I'm waiting for her to call back. I'm gonna try A. Now remember, if I show you this, you can select the same card, but you give it to me a different way. You can't use the same way I use. So the numbers are 2, 3, 9, and 14. So I'm going to try my best to solve the problem this way. I might be wrong, but I'm just going to try off the top of my head. So I'm going to say, okay, 14 plus 9 gives me what? 23, correct? Mm-hmm. I'm going to say 3 minus 2 gives me 1, correct? Yeah. And 23 plus 1 gives me 20. Oh! I know how to do China's 24. Yes, I do.
Now, if the callers call in, they cannot use that one.
You cannot use this way, the model, the way I just showed you to solve the problem with China's 24.
But there are always more than way for each card. So we're good.
That's what I love about math. It's always more than one way to solve a problem. Mm-hmm. So now what we're going to do is this. We're going to take a commercial break. Because I'm tired. I need some water. Working so hard. And after the break, we'll get back to your phone calls and your questions. And we might model some other things we're doing in our math classes this afternoon or today, okay?
All right. Don't forget, give us a call, 301-772-0080. See you on the other side.
Hi, I'm Cameron from Samuel Ogle Middle School, and today's email question is from Ted at Rockledge Elementary. Ted wants to know the area and perimeter of a rectangle that measures 3 inches by 6 inches. Well, let's start with the perimeter. The perimeter is round. So we add all the sides. Okay, so we know that if 3 inches is on this side, then 3 inches is on this side. And if 6 inches is on this side, 6 inches is on this side, because the opposite sides are equal. Now we add 6 plus 6. 6 plus 6 equals 12 inches. And 3 plus 3 equals 6 inches. Now 12 plus 6 equals 18 inches, which is the perimeter. Now we do the area. The area is the inside. So we can either count the squares or we can do length times width. And the length would be 6 inches and the width would be 3 inches. So let's do both. First, we'll count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So now we know that we have 18 inches squared since we used the squares. And the same thing goes for length times width. So now we do 6 times 3. 6 times 3 equals 18 inches squared. And this is the area. Well, Ted, I hope that was helpful to you. So that's Cameron, and see you next time.
Wait a minute. That's wrong. All people are people.
Take the time to get to know people, and you'll see that all of these labels are false. Don't let prejudice shape your view. Stereotyping is wrong, and it hurts all of us.
Stop stereotyping.
A message from your American Muslim neighbors.
When I was a kid, I dreamed of being a stuntman.
I went from dream to dream pretty quickly. I wanted to be a cowboy. Tom Cruise in Top Gun.
I dreamt of being a nun.
Actually, before that, it was Popeye.
Malaria kills more than 2,000 children a day.
Text NET, N-E-T, to 85944 to make a $10 donation to Malaria No More.
Oh, messaging and data rates may apply.
Let's make malaria no more.
Hey, welcome back. Welcome back to the second half of our secondary edition. Once again, I'm Mr. Pugh. They used to have my name down there, but don't have it no more. And
I'm Miss Walters.
it's her fault. It's her fault. It's her fault. So, and
oh boy,
you know, we here to help you guys out with any questions you might have for homework, any questions you may for a test or assessment, or things that you've just been going, I wonder about this in mathematics. Right. We are here for you. Any question, any from kindergarten all the way up to college. I think she does all the college questions.
Right.
Because she's the boss. She's the boss.
Actually, we go to algebra here.
And so once again, we have 2 challenges. Well, I'm going to knock it down to 1 challenge right now because I don't see no one interested in building blocks. But we have our challenge 24. And we still wait for a few students to call us back with some of those challenges they tried. But I believe Ms. Walters figured out one.
Yes, of course, with the help of my friend. Mr.
I didn't do anything. She's the boss.
Whatever. He is too much. Okay, so what we did, we looked at card 4.
Card 4, letter.
And we had 8, 8, 2, and 5. And of course, I was trying to do guess and check. I was doing all kind of things with these numbers. And then Mr. Pugh said,
I didn't say anything.
How much is 8 times 5? So I said, 8 times 5 equals 40. So I used those two numbers, and I had 2 and 8 left over. So then we said, how much is 8 times 2? 8 times 2 is equal to 16. And then 40 minus 16 is 24. So I had a little help from my friend. But we got it.
We got it. That's all that matters. We got it.
So if you call and want to try this one, don't give us this because we've already claimed this solution. Solve
That's
it a
right.
different way.
I like that solution.
Okay. All right.
While we're waiting for the phone call to come through, let me go over some things that we're working on in the classroom at my school.
Yeah.
At Ernest Everett Just Middle School. One of the best premier schools in the country today.
All right.
Why? But we have the best students at that school.
Wow.
And we have a few students that from our school is behind the camera right now.
Woohoo.
And a few students behind my school is at the board pushing the buttons that go from that frame to that frame. Because we're awesome at Ernest Just Middle School.
We have some talented students in Prince George's County.
Especially at Ernest Just Middle School. Especially at Ernest Just Middle School, yes.
He's biased.
Yes, I am. Yes, I am. So, at my school, we're working on with solving algebraic equations.
Okay.
Or more like 1 or 2 step equations. I had called, once again, the POE, but using the properties of equality. Because you all know in middle school, 7th graders, 8th graders, 7th graders, really, you already learned those 4 main properties early on in math. Identity, distributive, I can't say that word. Associative and commutative property. But there are 4 other properties you're going to learn as you go through your math, which is the properties of equality. So I'm going to show you how I start out with teaching one-step equations, okay?
Okay.
One-step equations. And I always introduce with vocabulary, but I like to integrate it as I teach.
Okay.
So, you always want to start out with so kids are comfortable.
Yeah, this is interesting because you're taking me from my point at elementary school and bumping it on up to see what you guys do.
Right, it's a migration. But you know what?
What?
We have someone waiting on the line.
We do?
Well, I'm going to put this on hold.
Okay.
Because I see one of my friends call back.
Okay.
One of my friends called back. It's that guy named Mohammed.
Is that you, Mohammed?
Mohammed, are you there? And this time, Mohammed, I hope your TV is turned down.
Yeah, it is.
Yeah, I can tell.
Thank you.
Yeah, I can tell. I can hear you much better now.
Yes.
So how can I help you with this, Mohammed?
Okay. I wanted to try challenge 24, but before I tried it, I want to ask a question about the formula of a cone.
A cone? Woo, work it, Mohammed. Work him tonight.
Man. Okay. You almost got me, okay? Now, cone. Let me show you. And Mohammed, when I show you this one, this is the last formula I'm going to give you for the night, Mohammed. Because you pushing me right now, Mom. Now, I like cones because cones remind me of my favorite thing. I'm a Jordan, like an ice cream cone. I had one of those last night. My wife fixed me an ice cream cone last night. It was, I know it's cold outside, but I love ice cream in the cold. That's your cone right there, Muhammad, okay?
Okay.
So I want to find cone. Once again, it's 3 dimensions, so I'm really finding the volume of a cone, okay? So once again, base times height. But this time, it's a 3-dimension figure because it's have 3 sides on there almost. So I'm going to say I'm looking to cheat a little bit. My base is equal to 1/3 pi. Is it 1/3 pi r squared times my height?
Wow.
All right, Mohammed?
Yeah.
Thank you so much.
Mm-hmm.
So now, you want to try your challenge 24?
Yeah.
Okay, Muhammad.
Oh, Muhammad, it made me sweat on that one a little bit, Muhammad. I had to cheat on I had to open my book that time, Muhammad. I'm going to tell you the truth.
Okay.
I opened my book that time.
Which
you didn't
one?
see it, but I did.
Which one do you want to do, Muhammad?
A, B, C, D.
B.
This one right here?
No, D. The last one.
Right here?
3 dots.
Okay, that's a tough one. That's a tough one. Oh, so she wrote it down for us already. Okay, now remember, Miss Walters just solved this one using her solution. You cannot use her solution in solving this, okay?
Okay.
Come on, talk to me.
Did you work it out already?
I'm thinking.
Are you thinking? All right, we give you a few seconds on live TV. We're gonna wait for you. We're on live TV.
We're on live TV. Well, since we don't have a call,
we can wait for a little bit.
A little bit. But tell us what you're thinking, so we don't have any dead air time, Muhammad.
Okay. I was thinking. It's 8852. So if I do 8 times 5 equals 40, and 8 times 2 equals 16. No.
And that would be the same as I just showed you guys. So if you can find another way to do it with those 4 numbers, that would be great. But that was the way I just finished working it out on television, on your screen. Okay?
What answer do I have to try to get?
24.
24? Oh, okay.
You were right with the 24, but that was the same way that I solved it. Can you find...
I have to use all the numbers to try to get 24?
Yes, sir.
Oh, okay.
Mm-hmm.
Okay. Okay, 16.
Okay.
Okay, let me...
He's not listening to you. He'll do the same thing again. He'll do the same thing again. So what are you doing now, Charles? Talk to us.
Okay, 5 times 2
is?
5 times 2 is 8.
5 times 2 is 8.
No, 5. No, I was trying to put the numbers.
Times 2 is 10. I tell you what, Mohammed, why don't you try working it out and then give us a call back, okay?
Okay.
And that way we can kind of work some more problems out here while you're working on that at home.
Okay.
And Muhammad.
Yeah.
What grade are you in?
8th.
Yeah. Oh, okay. I was wondering about your questions. And you all learning about formulas right now in your math class?
Yeah.
Is it tough learning formulas?
Uh-huh.
I can tell.
You can do it.
You can do it. You can do it because you have a good mind.
Mm-hmm.
Good motive. Call us back, okay?
And good initiative because you called us.
Good job.
Okay.
Thank you.
Thank you, Mohammed.
That's what we're talking about. We have excellent... Hello?
Yes, he's gone.
We have excellent students out here in Prince George's County Public Schools. And 3 years ago, I couldn't say that to save my life.
What?
Prince George's County Public Schools.
You stumble over it.
I used to say PGCPS.org, you know what I'm saying? Let's go back to my original thought. While we wait for another caller. And remember, we are here. Call us at 301-772-0080. We are here to serve you. If you're watching the show, call. If you're doing your math homework, call.
Please. We want to hear from you.
So now,
okay.
You all know, seen this problem since you was third grade.
Yes.
2nd grade probably. Now in today's schools, 1st grade.
Yes.
So, 2 plus 5 equals
7.
7. Mm-hmm. We are able to put 5 and 2 together to get 7, correct?
Yes.
Why is that? Because these two are called what? Constants.
Okay.
They are numbers by themselves.
Yes.
They are both called a constant. This is called a mathematical sentence, numerical sentence, math sentence, okay? You don't see no words, though, do you?
No words.
You see numbers and symbols.
Yes.
That's a mathematical sentence.
Yes.
But it's numerical because you see all what?
Numbers.
See all numbers, all right? So if I say, hey, let's take that 2 out and put a box there. You've seen this in elementary school, haven't you?
I sure have.
Right?
Yes.
And so in elementary school, you don't know you're doing algebra, but you're doing algebra. So what plus 5 would give me 7?
We have to find the unknown.
Right, which is? 2. Guess what, guys? So now I'm going to replace that with a letter.
Oh.
X plus 5 equals 9. Now watch this. Most kids like, man, what's that?
That's a times table.
That's something. I don't know. But my question to you is this. Can I add these two together right now?
No.
Why not?
Because they're different.
Now, I like how you like, she's so wise. She's so smart. But most kids going to say, they don't look the same.
Oh, okay.
That's a kid you can get in that class. They don't look the same. I don't know. That's a letter and that's a number.
Right.
Guess what? This is no longer a letter. We call this a what? Variable.
Does it always have to be X?
No, it could be N, as, it could be any letter in the alphabet.
Okay.
But those variable. What is a variable? It represents an unknown quantity. We don't know what X is. Now, mentally, you know what plus 5 give you 9.
4.
Right, which is 4, right? Now, but we don't know at this time what X actually is. We have to solve for X. But you just told me they don't look the same.
Right.
So we can't put them together, can we?
Nope.
Because we know 5. What's 5 again?
5 is a
Constant. And X is a what?
Variable.
So therefore, I have to take some steps in order to solve for my variable. Oh. So now you learned about this word called inverse a while ago.
Yes.
And remember, inverse means opposite. Or undo something,
Yes.
correct? But now this is an algebraic
Expression? No.
equation. Equal sign, right?
Expression
Why is it
is-
algebraic? Because it has a what?
Variable.
Now watch this. Now, I always teach my kids this. Equations are made up of 2 sides.
Okay.
Side A,
Side
side B. And my equal sign separates the sides. Side A, side B.
Mm-hmm.
Which side is my variable on?
A side.
It's on the A side. Is my variable on the side by itself?
No.
No. What's on the same side as my variable?
5. Your constant.
Positive 5. My constant, right?
Yes.
So I need to get rid of it. I need to undo that positive 5. How can you undo a positive 5?
You have to subtract. Or negative.
She's just a genius. I'm in a tag class. Now, most kids going to say, I don't know how I get X on the side by itself. You have to tell me, Mr. Pugh. You asking me all these questions all the time, making me come up and think all the time. I'm so sorry for making you think, son. But I'm going to challenge you anyway. So, yes, you have to subtract, undo, or what's the opposite of positive 5?
Negative.
That's when they get it. Oh, opposite positive 5? Negative 5. So I'm going to subtract 5 from both sides.
Okay.
But if I do the one side, I got to do the what? I got to keep it balanced, right?
Yes.
They cross out. So X is equal to what? 4.
Well, how do you just cross it out like that?
Because what's positive 5 minus 5?
Oh, 0.
0.
Okay.
And leave X on the side. Now, question for you. Is X on the side by itself now?
It is.
So X is equal to whatever's on the opposite side B.
Oh.
Now, guess what? You've been doing this since the 2nd or 3rd grade.
Wow.
And
how it changes.
And guess what? The same math skills you learn in the 2nd and 3rd grade, let's continue right now, and let's build off of that. The same math skills you learned in the 2nd and 3rd grade, it just keep on getting built. The only difference is now using all those skills at one time.
Yes.
So now if I give you another problem, 2x plus 4 is equal to 20. So now you're going, oh my gracious, I understand this a little bit. Now I have a number beside my variable, which we didn't have before. Because right now, off the top, you don't know what X is, do you?
No, I don't.
That's my variable, isn't it?
Yes.
It's unknown.
Yes.
It's not as simple as X plus 5 equals 9.
Correct.
So now that's just something we can build off on that can get your interest in, so you can feel good about yourself, build your confidence up.
Yes.
Now it's for me to take it away from you, okay?
Oh,
so I'm going
no.
to take it away from Ms. Walters, okay?
Please don't.
But once again, I give you my kids steps to follow.
Okay.
Like first step, always identify the variable.
Okay.
What's my variable? X. What side is the variable on?
A.
It's on A. Is it on the side by itself?
No.
No. What's over there with the variable?
4.
4 and
2.
2. Now, here's where it gets tricky. Now, step number 2 for me, always get rid of your constant first.
Okay.
Remove your constant from the same side as your variable if you have one on there. So what's my constant?
4.
4. Why is it 4 my? I'm talking about talk to my kids. Right? Why is 4 my constant? Give me an explanation. You have to know why. Because you know the right answer doesn't mean you always know what's going on.
Right. It's
So,
true.
but I'm not gonna talk to her because she's a genius. She's my boss, so she knows more than me. So I would subtract 4 from both sides. That cancels out.
Yes.
That drops down. 2x is equal to what? 16. Now, what you don't know, what I'm not saying is, what I showed in the last problem is, this is called the subtraction property of equality. Why is it called the subtraction property of equality? What operations did I use to get rid of that 4?
Subtraction.
Subtraction. Did I do it on both sides?
Yes, sir.
To keep it equal?
Yes, sir.
That's why it's equal. All right?
Yes.
So I use that property of equality. Now, question for you. Is X on the side by itself yet?
Nope.
Now, here's where it gets tricky. Most kids don't like this. Here's that big C word that most kids like. Miss Pugh, you lost me. You lost me, Miss Pugh. Especially those kids who who's not comfortable with math, who never liked math, who had a hard time with math.
That's because they never had us as a teacher. That's
Right,
why,
but this is where they start getting confused. Here's where you start getting lost. And here's where, as a teacher, I started trying to find those misconceptions. All right? So I catch you all before if I won't lose my students. So any number, or digit, I should say, any digit that's beside a variable, any digit, it could be anything beside a variable, that's called my what? Coefficient. But vocabulary is very important when you teach math.
It is.
Because the questions are phrased with these words in it. So if you don't use these words as you teach, your students, when they read the question, they get confused oftentimes.
But you know what? Because those same numbers are called something different in elementary school.
Really?
And then they give them another name.
But you know what? I like that. But I'm going to push back because I'm a middle school guy. She's a middle school world. But guess what? Like, when we use our everyday English,
yes.
As you get older, you mature.
Mm-hmm.
Your vocabulary matures.
Yes.
So like in math, as you get older in math, your vocabulary matures.
Wonderful.
Oh, my God. I just taught the master.
It's great.
I just taught the master. Yeah! So that coefficient. So whenever you have a coefficient, one operation comes to mind automatically, which means what, people? Yes, all the kids know this. Multiply, multiplication. Yeah. You must times. These are all those words in my class. So I'm asking you this question. So you all know it's multiplication. So what's the inverse of multiplication?
Division.
And yeah, division. Even my weak kids know that. Division is division. How you know it's division? Because when you multiply, it's the opposite of division. All right, cool. So
fat family.
So I'm asking you a question then. So if you know that division is the opposite or inverse of multiplication, and we trying to solve an x on the side by itself, what am I going to divide by on both sides? 2. And my 2 is known as my
coefficient.
Almost got her. Making her think a little bit. Now my kids in my class, I'll be doing that for the next 5-6 minutes. You understand me? So I'm going to divide both sides by what? My coefficient of 2. They cancel. It leaves x on the side by itself, correct? And I always tell my kids, they get frustrated with this because they have a hard time in elementary school and middle school with fractions because they don't really know what fractions are. Right. Fractions are nothing but division problems. That's it. It's division. So when I say 16 halves, I'm really saying 16 divided by what? 2. And everybody knows because it's an even number. What's half of 16? 8. But look, here I did my what? Division property of what? Equality. You know that now I have 2, right?
Yes.
Now, real quick, I'm just showing you how I build. I'm missing some stuff in between, but I'm just showing you the premise of how I build. So the next question, you might have something that look like this. 2/4 x minus 3 is equal to negative 27.
Oh my goodness.
So now, because now, as soon as kids see this, they automatically do what? I quit. I'm done. I can't do no fractions. Mr. Pugh, I hate fractions. I don't understand fractions. I said, boy, you better not quit, boy. Did I quit on you when I did that, boy? I did that all last night doing every single question for you, boy. You better not quit on me, boy. So let me finish. So then also I go from there. Then I start doing stuff like this.
They should not be afraid of fractions at all.
So they start saying, oh, well, it's a variable on both sides. What I do is the Pugh. You still use your properties of what? Equality. Then at some point, long time ago, I must have taught that right there. CLT.
Now, what is that?
Combining like terms.
Oh.
So I started using that. Then I started using the properties that I learned a long time ago, like 3 times 2x plus 4 minus 1 equal to 6x plus 7.
And you know what?
And we start building. And kids start understanding they're not afraid no more. Because they're going to use the same basic steps over and over and over again to solve each different question. Now, mind you, what I normally do, I show them one way. Then they feel comfortable. I got it. I put a different problem on the board that adds on another skill. And that's how I develop my mathematics in my class, mathematicians in my class.
Right. I love it.
Well, I know. I'm just give you a glimpse what I do.
But see, I like seeing that because I see how it builds.
Mm-hmm.
And then if elementary school teachers could take a look at what you're doing, they know what they have to shoot for with their students. Like, oh, okay, so that's what they're going to. So I need to make sure that they have this under their belts before they get to middle school so they can be successful in middle school.
Yeah. That's a collaboration piece we got to do between middle schools and high schools.
Mm-hmm.
We'll get there one day.
Oh, yeah.
Because know why? Prince George's County, I said it again, it's the best system in the world.
All right.
Well, it's almost that time for us to pull. We only have two names tonight. We either have Muhammad or Shakira.
Oh, boy.
Unless you want to try another challenge 24.
Do we have time?
Or building block. I think we have time. We have like 3 or 4 minutes.
Okay. Let's do a building block.
Nah, you're on your own on this one.
Okay, let me see.
I'm going to go for a picnic with my shirt.
What can we do? Oh, my goodness gracious. All right.
I know 40 minus 30 40 minus 10 is 30.
Okay. So oh no, we don't have that. I'm going to be like Muhammad. Call me back later on this one.
See, she stepped out there and got stuck.
I did, but I am not going to quit. I am going to persevere because that is mathematical practice standard number 1.
Oh, she threw it in there, the mathematical standard. Look at it. She thinks she's size.
I'm going to persevere. I'm going to do it off camera, though.
That's what I thought. Yeah, okay, boss. Yeah, right, boss.
Oh, so what else have you been working on in middle school, Mr. P?
Well, we have Springboard School. So
what does that mean?
We do a different curriculum right now. We don't follow the PG County pacing guide.
Okay.
So we went to Springboard, which is like a Common Core curriculum.
Okay.
So it's really struggling. So in the 8th graders, that's what we do in the 8th grade algebra classes, algebraic expression equations.
Okay.
I believe our 7th graders, they still working with, they just finished finding persistence of numbers, proportions, things of that nature, proportional reasoning.
So I think probably the biggest thing I got from what you were doing here tonight was you have to know your math vocabulary.
Also, another thing, we have to get our kids used to performance tasks. Tasks. So I promise you, next Wednesday when we come back, watch the show. Big show. Mr. Wednesday will be in the building. That's my name, Mr. Wednesday. When you see me in the street, hey, Wednesday. Mr. Wednesday. Numbers is my name.
All right.
So next Wednesday, I'm going to try to come up with a performance task as a challenge. I'm going to have a performance task as a challenge.
Okay.
And I
love it.
And I will provide a personal gift for the winner.
Oh, man. I think I'm going to call in that day.
Only for middle school kids, Prince George's County public schools.
Well, look, I persevered, and voila. I used the 8, the 5, and the 10. 8 minus 5 is 3, and 3 times 10 is 30.
Oh, that's good.
Hey.
But one thing she did, she used the parentheses first.
Yes,
She couldn't see the parentheses. She used the parentheses first because that's order of operations.
Yes,
so
I had to.
If you didn't see the parentheses, you should have said, hey, you had to multiply 5 times 10 first. Negative 5 times 10.
Right.
And that would give you negative 42. But you didn't show the parentheses on there, did you?
I did.
That's why we a tag team. We tag team.
They were in
Back
blue.
again.
They were in blue. He did it. He darkened it for me. Anyway, come on. Let's pull. Pull a name, Mr. Pugh.
I get 3 names in there.
Pull a name, Mr. Pugh.
Okay. I'm just asking.
All right. And the grand winner for this evening is
Mr. Pugh.
So silly.
Shakira from Potomac Landing.
Woohoo! All right, Shakira, congratulations. You have won a delicious Domino's Cinnasticks coupon.
Cinnasticks. Oh,
so enjoy them.
And remember, every Monday and Wednesdays from 4 to 6,
yes.
you can always count on us.